Professor Dave again. Let's make a connection.
He knows a lot about the science stuff. Professor Dave explains.
We just learned about all the different types of epithelial tissue, and we mentioned that these epithelia sit on top of connective tissue, which is the most abundant type of tissue. Connective tissue is incredibly important as it provides a protective structural framework for other tissues. So let's learn about the types of connective tissue in the body and their features. The four main kinds of connective tissue are connective tissue proper, cartilage, bone, and blood. A few of these may not seem like they would have qualified as tissue, so we must be aware that connective tissue does much more than just connect the body parts. Its functions include binding, support, protection, insulation, storage, and transportation of substances throughout the body. While these are rather disparate purposes, there are some things that all connective tissue has in common. They are all derived from a particular type of embryonic tissue called mesenchyme, and they are comprised not just of cells, but also of an extensive extracellular matrix. This matrix is what makes this type of tissue so good at withstanding lots of force or tension. Let's go over the main components of connective tissue now. Connective tissues are comprised of ground substance, fibers, and cells. And the first two of these components are what make up the extracellular matrix that we mentioned. Let's start with ground substance. This is the material that fills the space between the cells and connects all the fibers. It's made up of interstitial fluid, cell adhesion proteins, and proteoglycans, which to varying degrees act as a sort of glue. Embedded within the ground substance are the fibers, as we mentioned, and these come in a few varieties. Collagen fibers are the strongest, made predominantly of the protein collagen, as one might guess, which is the most abundant protein in the body. These proteins are assembled into cross-linked fibrils and then bundled together to form fibers. Gram for gram, these fibers are stronger than steel and prevent things from being pulled apart. Then there are elastic fibers. These are long and thin, made of a stretchy protein called elastin, and they form networks within the extracellular matrix. Lastly, there are reticular fibers. These are similar to collagen fibers, but they form networks supporting other types of tissue. With ground substance and fibers covered, that leaves us with the cells. These can be any of the varieties we listed earlier, and they can either be mature or immature, the latter meaning they have not yet differentiated or specialized. In this actively mitotic state, they will secrete the ground substance and fibers characteristic of the cell type they will become, and these have different names from the mature cells, ending in the suffix blast, which means they are forming. Connective tissue proper forms from fibroblasts. Cartilage comes from chondroblasts, and bones from osteoblasts. Blood cells come from hematopoietic stem cells, but as this is a different process, we will examine this when we take a closer look at the bloodstream. Once mature, the suffix blast becomes another suffix, cyte, leaving us with fibrocytes, chondrocytes, and osteocytes, among other types as well, such as fat cells and some others we will discuss later. Now that we have some general information down, let's look at each type of connective tissue a little more closely. First, connective tissue proper. This can be either loose connective tissue or dense connective tissue. These categories each have three subcategories as well. Loose connective tissue can be areolar, adipose, or reticular. The areolar variety has lots of fibers that support and bind other tissues, with lots of empty space for storing tissue fluid. This is the most abundant connective tissue, wrapping around some structures and cushioning others. Adipose connective tissue consists of fat cells, which store nutrients and insulate the body. And reticular connective tissue is similar to areolar, but with only reticular fibers supporting certain structures in the body. Now looking at dense connective tissue, this can be regular, irregular, or elastic. Regular variety is basically a bunch of collagen fibers packed together, with fibroblasts nestled in between, and this can resist a lot of tension, thus forming tendons and ligaments, which we will discuss later. The irregular type also has lots of collagen fibers, but they are not arranged in such an organized manner, offering resistance to tension in many directions. Lastly, elastic connective tissue is similar to the dense regular variety, but more elastic, as one might guess. So that covers connective tissue proper. Now let's look at cartilage. This has similarities with connective tissue proper because it too withstands tension, but it can also withstand compression. This makes it sort of an intermediate between dense connective tissue and bone. Cartilage lacks both nerve cells and blood vessels, so it receives nutrients by diffusion from blood vessels in a nearby connective tissue membrane. Cartilage also contains a lot of tissue fluid, which assists in withstanding compression. There are three types to be aware of. Those are hyaline cartilage, elastic cartilage, and fibrocartilage. The first, hyaline, is the most abundant. It is amorphous but firm, and thus good at reinforcing and cushioning structures. Elastic cartilage is similar, but has more elastic fibers in its matrix. This is the stuff in your ear. And then fibrocartilage is sort of in between dense connective tissue and hyaline cartilage, with rows of chondrocytes alternating with rows of collagen fibers, making it compressible but still great at withstanding tension. This is found in discs that separate the vertebrae of the spine. Next, let's take a look at bone. As we know, bone or osseous tissue is much harder than cartilage or connective tissue proper. The matrix of bone is similar to cartilage in that there is lots of collagen, but there are also inorganic calcium salts, and that's the component that makes bone so hard. Another difference is that unlike cartilage, bone does contain blood vessels. Speaking of blood, which is the fluid found in blood vessels, this is also the fourth type of connective tissue. It seems counterintuitive because it doesn't connect or support anything, but we call blood a connective tissue because it develops from mesenchyme, and blood cells are surrounded by a non-living fluid matrix called blood plasma. Since blood is so different from the other types of connective tissue we have just discussed, we will hold off on describing blood until we investigate the circulatory system. There are two more types of tissue, those being muscle tissue and nervous tissue, but we will delve into those when we discuss the muscular system and the nervous system. For now, let's move forward and investigate some other systems first. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.